Alright, so we'll try that, see if it's going to be recording. So here we go. Alright, so here we've got 5 songs where I actually don't have them all on videos yet. I have I worked on the box plot song yesterday, but we will be actually singing this independent one today, and I'll use that a lot through the whole year. In fact, that whenever that song came along, I didn't realize how much independence, the concept of being independent, happens throughout the year. It happens 4 or 5 times. I didn't realize that until I made that song, and I was like, oh look, we could sing this here. And then later is, oh look, the independent song. And so I really realized at that point how much independence, the concept of independence, tracks through our course. All right, moving on. And so here we go. We're going to start with our chapters 2 and 3 notes. We started the year with chapters 12 and 13 in our book because those were on experimental design. Those were on collecting data. Now we're going to talk about graphically displaying data and understand where they're centered and about how much they're spread out and all that kind of stuff. So here we go. First, there are 2 major kinds of data, categorical and quantitative. Now, in science class, you've called categorical something else, not quantitative, but do you remember what? Qualitative, good. So in science, you may be used to this being called qualitative, okay? And so those are labels, you know, word labels, or they could be numbers that are used as labels. So, for example, the colors of the M&Ms, maybe if we were going to identify the proportions of the colors of M&Ms in our sample, do you know an example of a number that could be used that doesn't make sense to average, but it's identifying, you know, a certain category or area or something? What kind of numbers wouldn't make sense to average? Nope, probably we would average time, like time of the day. Okay, time I think we would average. Just how about, well, for one, your phone number. Would that make sense to average phone numbers? How about zip codes? Isn't zip code a numerical value that really is a category based on where you are located, your area? So zip code is a good example of the number that is categorical and doesn't make sense to average. Okay, quantitative. These are your numeric values such that it makes sense to average them. So these are things, you know, we've done a lot of these, like your shoe size, your height, the time that it takes you to run a mile, those different things. Now, later this year, it's going to be really important that we identify these types of data because we will turn qualitative data into proportions. The proportion of blue M&Ms in your packet. The proportion of students in Aledo High School that are what's the zip code that's something like 76086? 008. There's 008, but there's another one. 087. So maybe we could see, and there's like not as many of those, right? So we could see what's the proportion of Aledo High School students that has the 76087 or whatever. Whereas with quantitative variables, these of course are means. And so later on in the year, we will have 2 different kinds of statistical tests that we'll have. A proportion test or a test for means. And so the very first thing you have to do is identify. So that's why this type, like talking about this, is so important. Because you have to first identify what kind of data it is. All right. So here's ways that we would display categorical data. Frequency table. I'm going to show you one of those. Bar chart, pie chart. So let's take a look at this frequency table. You guys did a frequency table when you did your bear hunt. Do you remember your person going behind you and tallying the frequency that you saw particular colors? And so you could do that tally. Now I want to talk to you about what this second column is. It is the relative frequency. So relative frequency is not just frequency. It is the frequency that is related, hence relative frequency, related to the total. So the count relative to the total. So relative frequency here would mean that I want to know how 13 relates to the total of 55 M&Ms in the bag. So 13 over 55, and 7 out of 55, and 11 out of 55. So those are the relative frequencies, not just the count frequency. And then, of course, you can turn those into percent. And you know how to do that, and we know that those are out of 100 and so on. Okay. Now, this next one, I'm going to explain to you or talk to you about bar chart and histograms. Because strangely enough, I didn't know the major difference between those two. I didn't know that there really was a difference. I just thought a histogram was a bar chart, and that's not true until I started teaching this class, and I just kind of like feel like I'm like, I've been a math teacher for 12 years when I started teaching this, and I didn't know the difference, or that there was a difference. So somehow that got kind of skimmed over in my math education. But a bar chart is used for categorical data. And I have drawn a histogram down here. A bar chart is not a histogram. And so what is visually the difference here between our bar charts and our histograms? What's the first thing? The spacing. Very good. So up here on the top, the bar charts are categorical data. The bars do not touch. The bars do not touch. And the reason that they don't touch is because they can go in any order. And they can go in any order. See, think about it. These are blue, red, orange, green, yellow, and brown. Could I change the order in which I wrote those colors? Yes. So that's a bar chart. That is why there are spaces in between those bars, because they don't relate to each other. Whereas down here in the histogram, we have quantities, quantitative data instead of categorical data. So these ones down here that are quantitative data have a number line. So there's numerical values that go from least to greatest, and one goes up to the next. So they do connect because they are numerical values that are a continuous value from least to greatest. Okay? All right. So there you go. There is a difference between a bar chart and a histogram, and they are not the same. All right. Any questions on that? Moving on. Okay, next I'm going to show you a picture of a stacked or segmented bar chart. Okay, so this would be where you can display several bits of information within a particular time slot or a particular category. So here we have category or quarter 1, quarter 2, quarter 3, and so on, but yet there's several categories within that quarter, within each quarter. Okay, it's a good way to tell. It's also, and we'll talk about this today, that it is a good way to tell if two variables are independent of one another or not. And we're going to get into that in a little bit. All right, and the last thing that I want to talk to you about with our categorical representations is this thing called the area principle. I actually have a color representation right here. Okay, let's go with this. So the area principle. So the idea of the area principle is that your area needs to look correct. I mean, it needs to look like what it is representing. So for example, here, these are the actual values, this little chart to the right. So you can see first class has 325, which is more than second class, which has 285. But what I want to ask you is, if you take a look at this nifty, handy-dandy, 3D, beautiful representation here, which one looks larger, first class or second class? Which one looks like a bigger section? Yeah, second class looks like a bigger segment. when in fact first class has more people in it. Okay, so that is a violation of the area principle. Okay, so here second class looks larger but actually has less people than first class. Okay. Now, let's take a look at our nice little 3D handy dandy picture. I want you to compare crew to third class. Crew and third class, which one looks bigger? I agree. I think third class looks bigger. But if you come over here, third class has 706 and crew has 885. So crew is supposed to be bigger. But the angle in which they drew that 3D shape distorted which one is bigger. So what do you call that? A violation of the area principle. Good. Okay, now here, let's explain, and I've come up with 3 major things wrong with this graph here, this pie chart here. So what's one thing? Okay, good. I like that one. That's so interesting. It's like response time. I don't know. It like takes everybody. Y'all just nothing. And then it clicks and boom, everybody talks at once. Okay, 50% does not look like half. Okay, good. That's one major thing. Oh, excellent. Look at these categories. If you are using alcohol, then your heavy drinking category is happening. So there's a major problem that the members of the categories overlap. So essentially a pie chart is not a correct way to represent this. Pie chart was a bad choice in the way to represent this because there's an overlapping. You know those Venn diagrams that look like this? See, now I could see that happening with the Venn diagrams because you could have some overlap there. All right. How about one more? Perfect. Does not add to 100%. Okay, good. That's the 3 major ones that I wanted you guys to catch. Good. Okay, moving on. So that is, in summary, the part about categorical data and how some quick graph concepts. But now we're going to go on to, I forgot when I wanted to erase on this. Let's see here. So now let's go on to the next section. Okay, so for this section, what we ultimately are trying to figure out is, because here's a problem. Let me go ahead and read you the situation for this page. It says, January 2013, a simple random sample of 3,000 Americans 18 and older were asked, what do you look forward to watching in the Super Bowl? And the choices are football game, commercial, or they're not going to watch. Okay, so what we ultimately want to know, why do you think that we might separate the data into males and females? Why do you think that might be interesting to us? To see if what? Sorry, say that one more time. Okay, well, we are wondering, is gender going to affect their choice? You know, does one gender like to watch for the game and one gender like to watch for the commercials, or what? Okay, good. So we are wondering, is gender and the reason for watching the Super Bowl, are they independent of each other? Are those 2 variables not affecting each other, or are they affecting each other? Okay, so that's ultimately what we're really wondering. So there's a way to do that. And what happens is you have to see if the fact that you are a male or a female is the fact that you are a male or a female changing the rate at which you watch things. So that's kind of also what we're wondering. is the fact that you are male, male or female, changing the rate at which you choose what to do with the Super Bowl. Okay, so we are going to do that by comparing the marginal and conditional distributions. So let's first talk about marginal. Marginal comes from this margin, and it is the totals. So over here, this column, that is the totals, is where I will get my marginal distributions from. Okay, that's the overall. Okay, so my first question is, overall, what proportion of the sample is watching the football game, for the football game? Overall, what proportion of the sample is watching for the football game? Good, 1,200 over 3,000 is 40%. So you're going to write that down. 1,200 over 3,000. Okay, good. So now, what proportion of the entire sample is watching for the commercials? 1,000 over 3,000. 1,000 over 3,000, which is 33 1/3%. And then the last one, what proportion do not watch? That's our 800 over 3,000. And so that's our 26 2/3. Now, let's draw a picture of it. So over here, I'm going to label this picture as, actually, you don't want these numbers on the bottom because this is categorical data, not numerical, so that those numbers shouldn't be there, by the way. So I'm just going to pick section. I'm going to make it about 2 sections wide, and this is going to be my marginal, or my total, or my overall. And I like, since I have won't watch next to it on the bottom, I'm going to do it where won't watch is on the bottom and commercials is above it and football game is above that. So I have 26 2/3%, so I'm going to graph that where I have 26 2/3%, that won't watch. And now I'm going to stack on top of that the percent that watch for commercials. So if I add up that 33 1/3% on top of that, what does that take me to? It will take me to 60. And the reason I knew that is because 40% is what was left. And so then this is my commercial section. So it gets dots. I made that one dots. And then I finish out my bar to represent the total of my sample, and I go up to 100%, and that is the 40% that are watching for the actual game. Okay, so that's my marginal representation, stacked bar graph. Okay, so now, next let's talk about conditional. Okay, let me erase my numbers here. So conditional values upon being a male or a female. That's what we're interested in now. And so here, I'm going to highlight this in a different color, is this section here is the conditional data. This is conditional upon you being a male or a female, the rate at which you watch the game, watch for commercials, or whatever, okay? So this section here is the conditional. We'll get our conditional distributions from that little section there. All right, so we're going to start with the males. And so what proportion of the males watch for the game? How do I get that? What's the proportion? Good. See, I am looking at this section here. So 720 males out of the 1,800 males are watching, and that comes out to be the magical 40%. Okay, what proportion of the males are watching for the commercials? Okay, that's the 600 over 1,800, 33 1/3%. And then the last one, 480 over 1,800, which is the 26 2/3%. Okay, good. All right, now, conditional upon you being a female. So that's going to be this section here. What are those numbers? Do you see that the reason we're having to turn these into percents? Well, let me ask you this. Why do you think I'm going to the trouble of turning these into percents? Okay, you can graph it easier, that's true. There's another more primary reason. Perfect. When I did my sample, I did not get 1,500 males and 1,500 females. I got a different number of males and females. So what I have to do is, get them to be a common denominator by turning them into percents. So my females was 480 out of 1,200 in the sample, and that is 40%. And 400 out of 1,200, which is 33 1/3%. And the last one, it's pure magic, is 320 out of 1,200, 26 1/3%. Okay, so again, it's critical that you turn these into percents, because let's just look at the straight up numbers. If you just look at the straight up numbers, look, 720 males, 720 males are watching the football game, and 480 females are watching the football game. So can you say more males are watching the female, or more males are watching the game? Can you say that a higher proportion of males are watching the game, the football game? You cannot, because this is 720 out of 1,800 and 480 out of 1,200. Okay. All right, so ultimately, is the fact that you are a male or female changing the rate at which you watch the game for commercials or the game? No, it is not. These numbers, these conditional numbers, are staying the same as this overall rate. So the fact that you are a male or female is not changing the rate. So that takes us to our little song, which goes, independent, 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 when the fact that you are one thing does not change the rate. And I use that wording when I am describing my explanation. So when the fact that you are one thing does not change the rate. So in this case, when the fact that you are a male or female is not changing the rate of the reason why you're watching the Super Bowl. Okay? So therefore, ultimately, my question being, are gender and reason that you're watching the football game independent? And that answer is yes. And look at how I described it. I did the picture there also, so I'll let you do that here in a second. The fact that you are male or female does not change the rate at which you watch the Super Bowl. I mean all those categories. Does not change the rate of the reason for which you watch the Super Bowl. Okay? And then, by the way, I went ahead and I did my stacked bar graph for the conditional, male and female. And so, since those are the same, you can tell, again, that the percentages stayed the same. So the fact that you are male or female does not change the rate at which you watch Super Bowl for game, commercials, or won't watch. Okay, now what I would like for you to do is the next one. So I'm going to give you a few minutes to figure out all of these ones here and to graph them and to determine independence. So if the numbers were those, is our gender and reason for watching the Super Bowl independent? Okay, so do that. You did on this. Okay, so here we go. So again, our males and females is our conditional, and then the totals is our marginal. So overall, from the marginal, I got those numbers there. I get a question on, does it matter how you do the bar graph, where you put the numbers? Some people did it upside down. That's fine. So it does not matter the order in which you do your bar as long as the conditional ones are done in the same order. So as long as you're always putting a certain one on top and the certain one in the middle. Okay, now when I did these by conditions, here's the numbers that I got. Okay, so I got, for the males, 50% watch the game, 33 and a third watch the commercials, and 16 and 2/3 don't watch. Okay, but it was different for the females. All right, so what does that say to you? What is that telling you? That the fact that you are male or female is affecting the rate at which you watch. The fact that you are male or female is affecting the rate at which you watch. Now, when I did my picture here, it looked like this. So there was my chart. And here's what I want you to write. Here's the conclusion. And I might erase this so I can write it with you. Okay? So, are they independent? No. Because the fact that you are one thing is changing the rate. Okay, so when that happens, then you're going to explain it by saying that, no. The fact that you are male or female changes the rate at which you watch the Super Bowl. Watch the Super Bowl for game, commercials, whatever. For the game, commercials, or won't watch. Okay. But then in this case, they're different. So I want an example. So on this one, I want an actual numerical example. So which one do you want? Which one stands out to you? What do you want to say? For example, there's lots there. There's 6 different ones I could do, I guess. Which one do? For example, who? Perfect. Males, watch the game at a much higher rate than females, and put the numbers in there. Parentheses, 50% versus 16 and 2/3%. Okay? So, for example, the males watch the game at a much higher rate than females. 50% versus 16 and 2/3%. Okay? All right. So that's independent and not independent. And our nice little ditty to help us remember the way it goes. Okay. Now, the last thing that I want us to do is actually, let's go ahead and do a couple of these graphical displays. Let's look at some graphical displays and determine if they are or are not independent. So this first one, now those 2 bars have to do with one's based on a male and one's female. Okay? So what's happening there? Is that independent or not independent, number 1? Not independent because they are watching things at a different rate. Now on number 2, it's interesting. You're looking from side to side, so you can see that you know, the percents are the same across the categories. So that this must mean, you know, like there's 60% of the males are in the sample. The sample is made up of 60% males and maybe 40% females. And so that's why these numbers are different, but they stayed the same across the categories. So every single time the categories were like the total. So is this independent or not independent? The fact that you are one thing does not change the rate. The rate's not changing. There is still, in every category, there's still the same, you know, 60% males and 40% females. Okay? Moving on. Number 3. How about that one? There's a stacked bar graph. Is that independent example or not independent? Yes, it's independent. Number 4. Not independent. Number 5. Yes. Number 6. No. Good. Okay, moving on. Now, this this worksheet here is new for me this year, and the reason is because technically you can do your fractions in 2 different directions. You know, you can go up to down, or you could even go across, like 720 out of 1200 and 600 out of 1000 and such. Okay, so you can do your fractions in 2 different directions. And so I was getting a lot of people, some people would do their fractions one direction and I'd do my fractions the other direction. And they say, why are you doing your fractions that direction? So after thinking about it last year, I was like, I kind of figured out why. I was doing some in one direction instead of the other. And here's the reason why. So I made this up for us. Let's talk about it. So when you are determining independence, which is what we're going to do a lot of, it makes sense in the problem and in your conclusion if you get your marginal and conditional probabilities based on the variable that is explaining the response. So for example, in this problem that we have been doing, we have gender and reason for watching the Super Bowl. Which one of those is explaining the other? Is gender explaining the reason for watching, or is the reason for watching explaining your gender? Okay, good. So the gender is the one that's the explanatory variable. So since gender is the one that is the explanatory variable, then you will collect your data and do your fractions, and it'll make most sense in your conclusion if you do them in the direction of those conditional and marginal based off of that gender. Okay, so let's do this next one. So this problem is based on type of driver, student or staff. So we're wondering is student or staff, there's student and staff going on, and then the type of car owned, the origin of the car, American, European, or other. So which one are you wondering if it explains the other one? Which one explains the other? Student or staff does what? Explains your type of car. So that's what we are wondering. Is the fact that you are a student or a staff member changing the rate at which you are driving an American, European, or other car? That's what we want to know. So if that's the case, then we want to do our fractions in this direction. Okay, we want to do it based off of the student and staff and total. So we're going to do our fractions in this order here. Okay, so that means, so what I'm also going to have you do on your assignment is I'm going to have you write conditional. So of course, our conditional probabilities are the ones based off of what? You being what? Thank you, student or staff. And then of course the marginal is the total. So I'm going to have you go ahead and kind of write out what that would look like, how your data would be collected. For example, we would have a student column, and we would have a staff column, and we would have a total column, and it would be based off American, European, and other. And I want you to do fractions, but I'm not going to require you to do them all. I just want one set of fractions. So let's do the student fractions. What would the numbers be like for American out of the students? Good, 107 out of 195. And European out of the students? Okay, good, 33 out of 195. And then the last one, other, 55 out of 195, okay? And then you could do the other categories, then that would allow you to say, based on you being a student or staff member, if it increased or decreased your propensity to drive a particular kind of car. All right, let's take a look at this next one. Does age category, under 30, 30 to 49, or over 50, affect your blood pressure type, low, medium, or high? So I want you to take about 5 seconds, well, 5 or 10, whatever. I want you to think in your brain, don't say it out loud, think in your brain which one is explaining the other, and I want you to tell it to somebody beside you. Tell them which one explains the other. Go. Okay, so which one explains the other? Good. Age explains we're seeing if age affects your type of blood pressure. So therefore, this is the direction that you will do your fractions. See how that's different? Because that'll allow us to say the fact that you are over 50 makes you have, more higher percent chance of being high blood pressure or whatever. And then I want you to write over here to the left. These are the conditional. Remember, I'm wanting you to write that these are the conditional ones. And then this total is the marginal, because that's going to stress to us that vocabulary word. So the conditional are those little subcategories. And then the marginal is the total. So let's just envision how our data will look for that when we collect our fractions. I'm going to have, what are my categories going to be? What are going to be the title heads that I write down? Yes, good. Under 30 is going to be one of my groups. 30 to 49 is going to be another group. Very good. And over 50 is going to be the last group. And now, underneath each one of these groups, what do I have? Good. Low, medium, and high. Good. So let's do one set of fractions just so we make sure we're going in the correct direction. So what is the low under 30 amount? 27 over 98. Good. And the medium? 48 over 98. Good. So that means out of those in the under 30 category, here's the rate at which you had these blood pressures. Okay. Very good. And you could do the other ones as well. Okay? All right. So what I'm going to have you do is the back, and we've got some time here at the end of class, so I'm going to have you do this first one, and you actually might be able to finish the others if you're just really speedy. So I want you to draw the circles and do the arrows, the direction that you're going like we've just done. Label it continual or marginal, conditional or marginal. And then, give the example of the numbers below like I did on the previous page, how you would set it up and do fractions. So basically, do on that just like I had done on these two items here. Okay? Don't forget your arrows in there of which way you're going to do your fractions. Okay, so let me give you a few moments to do that one, and then I'll let you check it. All right, let's go ahead and check those. See how you did on that. So I'm thinking that your employment status is affecting you owning a vehicle, or owning a phone, sorry, vehicle too, but so therefore I went left to right. So my categories are my conditional, employed and not employed in my total. So I put the fractions there so you can double check yourself and make sure you're doing your fractions correctly. 25 over 93, 68 over 93. So see, then I'm saying the rate at which an employed person owns and doesn't own a phone, and a non-employed person owning and not owning a phone, and so on, and overall what it is. Okay, so I want you, for your assignment, to finish these other three. By the way, I will tell you the bottom section has a couple of totals that I just have no idea how I got. So there are three numbers that you might want to consider fixing if that really annoys you, that the fractions aren't correct or they don't add up to what they're supposed to. So you can fill those in. On the last one, early discharge total is 4619. Not early discharge is 5219. And then the one on the side is 8657. All right. So do those three, and that's what you're going to do today.